Hello, good morning everyone. In this session, we are going to learn about field identification of soil. We have studied in length in the laboratory what are the tests to be conducted and then how to classify the soil. Suppose we have to make the identification of the soil instantly when you are standing on the field. What are the ways and means how we have to find out the type of soil? That is what we are going to discuss in this session. Okay, field identification of soils. Basically, coarse-grained and fine-grained soils are distinguished based on whether the individual soil grains can be seen with naked eye or not. Thus, grain size itself may be adequate to distinguish between gravel and sand, but silt and clay cannot be distinguished by this technique. Okay, what it means is you know the size of the sand or gravel, etc. Gravel are the particles which are bigger than 5 mm. Exactly, to be exactly, it is 4.75. We can make out from here. It is 4.75 size particle if it is, or if it is greater than 4.75, we recognize it as gravel. And then if the particles are visible to the naked eye, but they are smaller in size, like small grains like that, it is not amorphous mixture or powder. If the particles are smaller than 4.75, but individual particles can be recognized, then we may classify it as sand. That is what is said here. Sand and gravel can be identified with naked eye, but it is difficult to distinguish between the clay and silt particles. It is quite difficult. Then there will be some ways and means how we can do it instantly on the field. That is what we are going to study in this session. Field identification of soils becomes easier if one understands how to distinguish gravel from sand, sand from silt, and silt from clay. I have told just now gravel from sand. Anyway, we are going to see it through some more slides. Okay, here in the first sketch or the photograph, we have particles quite bigger than 5 mm. You can hear there is a tape which is opened, so 4.5 if I mark, so something like that. 5 mm is the size over here. So almost all the particles are bigger than 5 mm or 4.75 mm to be exact. So we can say that it is gravel particles. So starting size is 4.75. It goes up to, here it is written, it goes up to 80 mm. So 80 mm in the sense 8 centimeter. Here I have a photograph in which around 6 centimeter is spread. So all these particles, even though those are bigger in size, all of them together contribute to the gravel, right? So here you can just read individual soil particles larger than 4.75 and smaller than 80 mm are called gravels. Of course, in between you have seen that 4.75 to 20 mm it is called fine gravel or smaller size gravel. 20 to 80 mm it is referred to as coarse gravel. But anyway, total range from 4.75 up to 80 mm, it's all gravel. So just by looking at the soil particles, one can readily recognize that it is gravel or sand. Now, photograph below has got particles, almost all of them, leaving one or two here and there. Almost all of them are less than 4.75. Moreover, it will be grainy in texture, means you can hold in hand and then just feel the soil grains. So such soil will be referred to as sand. Okay, here it is written soil particles ranging in size from 4.75 mm down to 0.075 mm are called sand. These limits, although arbitrary in nature, have been accepted widely. The shape of these particles is also important and may be described as angular, subangular, or rounded, etc. So you can just see it is subangular, all these particles. If you find them very smoothly rounded off, then it is rounded or angular when it is broken, like there is one piece over here which is broken, and then if it is not undergone a lot of running through the water, obviously the particles will be possessing sharp edges, so they are referred to as angular. And then now here you have subangular, and then very smoothly rounded off one will be rounded. So from this slide, I think you are able to recognize what is gravel, what is sand. The size range is, you can just recognize this is 4.75 or 5 mm would be the reference size. The particles which are greater than 5 mm are referred to as gravel. The particles which are lesser than 5 mm, but the sizes of the particles can be felt maybe through the eyes or maybe through hand also. Such ones will be referred to as sand. Okay, now how to differentiate sand from silt? That is what is discussed in this case. We'll see sand from silt. Fine sand cannot be easily distinguished from silt by simple visual examination because almost they look the same. Fine sand in the sense 0.075 mm to 425 microns or 0.425 microns. So very small size particles are there, but they are not silt. Silt is a particle which is 0.002 to 0.075. It is lesser than 0.075 but up to 2 microns. So these particles are difficult to recognize visually, right? So that is what is said in this. Now silt may look a little darker in color. However, it is possible to differentiate between the two by dispersion test. Now what is dispersion test? We will discuss here. This test consists of pouring a spoonful of sample in jar of water. If the material is sand, it will settle down in a minute or two. So very important point that to be noted. In a minute, a spoonful of soil, when you pour it inside this, right, all the soil particles will be settling down, then it will be sand. But if it is silt, it takes around 15 minutes to 1 hour to settle. In both the cases, nothing may be left in suspension ultimately. Means no particles are left in this. When you got a muddy water like that, it indicates that there are clay particles which are involved, the particles which are less than 0.002. But in this case, you can see almost all the particles have settled down, indicating that it is either silt or clay. But settling, if it takes within a minute, then it is sand, and then if it settles in 15 minutes of time, then it can be recognized as silt because the particles will be smaller. It takes a lot of time for it to settle down. What is dispersion test? A spoonful of soil is poured in a jar of water. If it is silt, the same thing is written. The particles will settle in about 15 minutes to 1 hour. If it is clay, it will form a suspension which will remain as such for hours together, even for days, provided flocculation does not occur. Means the particles which join themselves to make a bigger size particle, that is called as flocculation, and if it is not happening and if the particles are individually acting, the clay particles will be taking a lot of time to settle down, whereas sand particles or silt particles will be settling down in the suspension quite quickly. That's how you can differentiate between sand and silt. Okay, silt from clay. So silt size is 0.075 to down up to 0.002, whereas clay particles are lesser than 0.002. So obviously it is not possible by just by looking at the size of the particles, because the size is too small to be recognized by even naked healthy eye. Okay, now what is done? We'll see, we'll read it and then we'll discuss. It is called dilatancy test. It consists of placing a pat of moist soil in the palm of the hand and then shaking the hand. Now, how to shake the hand? It is given here. One palm, you got a soil. With another palm, it is tapped continuously by holding the hand like that and then tapping it. Right? That's how the shaking is done. Not that you have to shake the hand, but you have to tap your hand with the soil by some light strokes. Now if you do that, if a shiny moist surface appears on the soil after shaking it in the open hand and then becomes dull and dry when the pat is squeezed by closing the hand, a non-plastic soil is indicated. Now what it means is, if a shiny moist surface appears on the soil after shaking, it has appeared now, it is shiny, and then when you squeeze it, a slight squeezing has been done. Now you can see here, it has become a bit dry on this side because of the light. It is shiny, but on this side you can see that it has become dry, means whatever moisture that has appeared on the surface over here, when you squeeze it, it has gone inside. Now this indicates that it is a non-plastic soil. Non-plastic in the sense it is a silt, right? If it is not able to retain that shine on the surface, then we can say that it is silt, because the volume increase will absorb the soil inside, whereas if it is clay, there is no way that the moisture is readily taken inside. It is not that easy. That's how we can say that it is clay, right? So note, squeezing the pat, on the second photograph they have shown the squeezing the pat causes shearing deformation in the soil, which in turn cause a non-plastic soil to expand from the low volume obtained by shaking. When you shake it, it will be getting into smaller volume. When you squeeze it, obviously the volume expands a little bit. The water flows into the soil to make up the increased volume of the pores and thereby leaves the surface with a dry appearance. You can just see here. So you can readily recognize that it is silt. If it is clay, what happens? The water cannot move easily and hence it continues to look darker and shinier. Right? If it is a mixture of silt and clay, the relative speed with which the shine appears may give a rough indication of the amount of silt present. This test is also known as shaking test or water mobility test, or more familiarly known as dilatancy test. Right? If after shaking, the obviously on the surface a shiny surface comes, but when you squeeze it, if it disappears, if the shiny surface disappears, it indicates silt. If it continues to shine even after squeezing, then it will be clay soil. Okay, next, strength test. Now what is being done here is a sample of soil which is dried in natural condition. It is being held between the two fingers and then tried to press it. So whether the module breaks or not, that is what the test says. We'll read it off. A small lump of soil is dried slowly. Then the dry sample is tested for its dry strength by trying to powder the lump between the fingers. Means first of all you have to take the soil, sprinkle some water or move it and then dry it first of all, and then same lump of soil is picked up and then try to squeeze it. Right? If it can be broken easily or powdered with the fingers, the material is silt. It will not be possessing much of strength. So if it can readily can be broken, easily can be pressed, and then particles can be separated, then it will be silt. Right? If it is clay, it will require a lot of effort to break it. Right? If you are not able to squeeze it easily, then you can say that the lump consists of clay particles more. Also, if it is silt, one can dust off loose material from the surface of the lump. Means you can hold the soil, you can just rub it off continuously, you can take out the material from the surface. So that's how we can say that it is silt. When you go on rubbing, obviously all the particles will be getting separated from the surface. That's how we can say that it is silt. For clay particles, it is not easy to remove the particles from the surface. When moist soil is pressed between the fingers, clay gives a soapy touch. It also sticks to the fingers, dries slowly, and cannot be dusted off easily. So if it is silty, obviously it is not soapy to touch, grainy to touch, right? And then it sticks to it doesn't stick to the fingers. If it is silty, it doesn't stick to the fingers, but if it is clayey, it sticks to the fingers and dries slowly. So with this strength test and then some more observations, one can recognize whether the soil is clay or silt. Okay, plasticity test or rolling test, both of them help you to find out the amount of the clay only. We'll read it off. A measure of plasticity of a soil can be obtained by noting how much working of the soil between the fingers is required to dry it from the wet state near the liquid limit to crumbling state, that is near the plastic limit. The greater the plasticity, the longer the kneading time required. The reasons being, if it can take a really good amount of time to dry the soil, then it will be clay, right? So the more plastic the soil, the larger the difference in water content between the wet and crumbling states. The more plastic the soil, more the effort required to expel a given quantity of water. This is because silts possess little plasticity. They can usually dry after a few minutes of working with fingers, but in clay soils it takes a lot of time. Rolling test. A thread is attempted to be made out of moist soil sample with a diameter of 3 mm. There will be a reference rod which will be given for comparing, that is 3 mm rod will be given, so that you can compare whether the size achieved is 3 mm or not. You will not be measuring the diameter by scale, right? There will be a reference a rod of 3 mm which will be given. Using that, one can compare and then make a judgment. Okay. Now, If the material is silt, it is not possible to make such a thread without disintegration of crumbling. So if it is more of silt is there, it will be breaking like that. You will not be able to make it a full-fledged thread of 3 mm. Right? If it is clay, such a thread can be made even to a length of around 30 centimeter and suspended by its own weight when held at the ends. And this is also called toughness test or strength test. You can that 3 mm 30 centimeter thread can be easily picked up by holding the ends. It will not be breaking. That shows its plasticity, right? If it breaks in between while lifting itself or while rolling itself, it indicates that it is having a lot of silt rather than clay. Okay, so few more tests are there. A few more miscellaneous identification tests are as follows. Organic content and odor, if you want to know. Then what is done is, a fresh wet organic soil usually have a distinctive odor of decomposed organic matter, which can be easily detected on heating. So when you heat, there will be objectionable smell will be there if it is organic soil, right? Another distinctive feature of the soil is its dark color. If it is organic soil, it will be having dark color. Acid test. This test using dilute hydrochloric acid is primarily for checking the presence of calcium carbonate. For soils with high value of dry strength, a strong reaction may indicate the presence of calcium carbonate as cementing material rather than colloidal clay. Shine test. Now, when a lump of dry or slightly moist soil is cut with a knife, here it is being cut, here also it is cut off. Soil is cut with a knife, a shine surface is imparted to the soil if it is highly plastic clay, while a dull surface may indicate silt or clay with low plasticity. Okay, with this I think we'll stop. Thank you.